Good day, learners. Welcome. In our lesson today, we're going to do geometry of 2D shapes. We're going to classify and investigate triangles. Did you know that when the sun casts a shadow on an object, it forms an angle? In the olden days, they used that angle to tell the time of the day. The shorter the angle, the shorter the shadow, the more it was midday. And if your shadow was longer, then they said it was late in the afternoon. Our objective for this lesson are such that you should be able to identify and write clear definitions of triangles in terms of their sides and angles, distinguish between equilateral triangles, isosceles triangles, and right-angled triangles, investigate the angles of a triangle focusing on the sum of interior angles of a triangle, the size of the angles of an equilateral triangle, the sides and base angles of an isosceles triangle. We developed a concept map where we said in order for us to cover those areas, we are going to first identify triangles, and then distinguish between triangles, and then investigate triangles. All these would be our 2D shapes. You should, however, be able to accurately use a protractor to measure angles and to classify angles. Firstly, let's define the terms. What is an acute angle? An acute angle will be an angle that is less than 90 degrees. Less than 90 degrees. An obtuse angle will be an angle that is more than 90 degrees, but less than 180 degrees. Complementary angles would be angles that are, when added together, they make up 90 degrees. So they add up to 90 degrees. And supplementary angles would be angles that add up to 180 degrees. We are to use a protractor to measure a marked angle and name the angle. There is a picture of an angle that we have to measure. Let's get a protractor and do that. Here's our protractor. We are now going to measure the angle. I am using an online protractor. It's a similar one to what you would have in your maths instruments set, and then mathematical set, sorry. We're moving the protractor to the vertex of the two. And there. The protractor is where we want it to be. And now we are measuring the angle. So we put pins. This is where we put the first pin. And that is where we put the next pin. And as we do that, you'll realize that it's not on the line. So we move it up to where the line is, and there it is. So we've got our angle, which is 140 degrees. So that's how we put the protractor. You'll put it in such a way that where we are going to measure from, that line should be horizontal with the 0. There are two marks. There is the marking that is blue, which is from 0 to 180. Then there is the marking that is black, and it is from 0 on the left to 180 on the right. So it depends where your angle starts from. Your angle starts from 0, from the horizontal line that you used as the base, and where the angle begins, that's where you put your 0, then you move with it. So in this case, the 0 starts with the first pin, and then we move to 140. That is where the line is. that is how wide our angle is. So it reads for us the degrees, and it's 140 degrees. Let's look at another angle. This one, it's an angle less than 90 degrees. It's an acute angle. And as you can see, again, the protractor is starting from 0 to that degree, which I don't know. So I'll put a pin where it begins and put a pin on the line, and it reads 52 degrees. So it's an acute angle, which is 52 degrees. Look at the next diagram. It's a straight line. And as I put the ruler on it, you'd realize that it starts from 0 to 180 on the blue line, and 0 to 180 on the black line as well, because that's what a straight line would give us, 180 degrees. And then when we look at the next diagram, which is B, it is a revolution, which means it's 180 plus another 180. So if we were to put the ruler there, we would then use, let's remove that. If we drag the ruler and we put it there, we'll then tilt the ruler around so that you are able to see that as we turn the ruler around, it would give us 180 degrees again. Let's tilt it 180 degrees. There we are, 180 degrees. So our ruler turns according to the degrees we want it to turn. And I think we've moved too much. There. So 180 degrees plus 180 gives us 360. So now we are convinced that a straight line gives us 180 degrees and a revolution gives us 360 degrees. Let's move to the next one. Turn the ruler over. Zero degrees. Let's turn the ruler over and measure that angle. As you can see, the original angle is 90 degrees. So I've got my pin where it begins. I've got the first angle, and the first angle is 50 degrees. And then I can either turn my ruler or I can measure it from there to the next one. And it says the first angle is 50 degrees, the next angle is 40 degrees. So we are now able to see that these are complementary angles because they add up to 90 degrees, and both of them combined would give us 90 degrees. So that is how we use our protractor, and that's how we measure angles. Let's then go back to our diagrams. Question 6, identify each shape and list its properties. Let's look at the first shape, A, B, C, D. And that is a square. How do we know that it's a square? Because the markings on the sides of each side of the square are equal. Because the markings are the same, therefore this makes it a square. So all the sides are equal. That's one property that we know. All sides are equal. All sides are equal. And then all angles are 90 degrees. There is an indication there that the angles are 90 degrees and each angle is 90 degrees. So all angles are 90 degrees or are equal to 90 degrees. All right, let's look at the next one. PQR is a triangle, but then let's look at the markings on the triangle. You'd see that there is a single mark on each side of the triangle, therefore that makes this and the next shape is PQR, which is a triangle, and we look at the markings on the triangle, you'd see that there are single markings on each side, therefore that means all the sides are equal, therefore this is an equilateral triangle. So that's the name of the triangle, because all the sides are equal. All the sides are equal. And therefore, that would be an equilateral triangle. Let's look at the next one. And again, what we understand about an equilateral triangle is that therefore all the angles are equal as well. All the angles are equal to 60 degrees. We'll need to prove that. Let's look at the third one, which has different markings than the first one. What you would notice is that on side EH we have 2 markings and side FG has 2 markings as well. So that means these are opposite sides, and therefore these are the sides that are equal. So the opposite sides are equal. Look at the other one. You have 3 markings on side EF, and on side HG you have 3 markings. Therefore the opposite sides are equal. And what type of shape would that be? That is a rectangle, because it's only a rectangle that would have opposite sides that are equal. So this is a rectangle, and therefore a rectangle, and opposite sides are equal. And look at the angles. All the angles are 90 degrees. So all angles are equal, and they are equal to 90 degrees. So that is a rectangle. And the one before, this was we said it was an equilateral triangle. Equilateral triangle. And the first one was a square. Okay. New words that we're going to talk about today is equilateral triangles. That is, all the sides of the triangle are equal. And for an example, we have a picture there of the pyramids in Egypt. All the sides of that triangle that we are able to see from that side, all the sides there are equal. So it's something we've been used to, but we're maybe not aware that it's an example of an equilateral triangle. Let's look at the next one. It's a scalene triangle. The scalene means none of the sides of the triangle are equal. The example of that one is a set square that we have in our mathematical set that has 3 angles: the right angle, 30-degree angle, and a 60-degree angle. When you look at that ruler, you'll now realize that is a perfect example of a scalene triangle. The next word we are going to learn is isosceles triangle. 2 sides of the triangle are equal. An example is the chips, the regular chips that you would eat. When you look at them, you would see that 2 of those sides are equal, whilst the other one is different from the others. That then is an example of an isosceles. We can also find it in the bread. When we make sandwiches, when we cut the bread, you would realize that the 2 sides of the slice are still equal, but the one that we have cut has become longer than the other 2. So those are examples of isosceles that we live with every day, and maybe we're not aware that it's maths in the making. For now, let's go for an ad break. See you shortly.